All right, so now we are going to do the fall 2021 AMC 10A problem 22. My voice was a little shot over the last couple days, so I didn't really film, and then I had some internet troubles, but we're back now. Inside a right circular cone with base radius 5 and height 12, obviously 5, 12, 13, are three congruent spheres, each with radius r. Each sphere is tangent to the other two spheres and also tangent to the base inside of the cone. What is r? I'm going to try and draw this as big as possible just because let's see if we can get this going quickly. We have to draw kind of some complicated stuff inside. So you know the radius here is 5. If I can draw some on the side, okay, 5, and then your height is going to be 12. Okay, and then obviously this is 13. Now the sphere part, you have to kind of think about how it's going to be able to touch the sides going around the cone and each other. If they're all tangent to each other, their centers, and this is probably an important observation, are going to form an equilateral triangle. And one of the things about spheres and circles in AMC problems especially, or math competition probably in general, is a general principle. If you don't know what else to do, connect their centers. Just do it. And do it and then look at it and then see if it helps you. So what I'm going to look at here really quickly, I'm going to draw just on the side kind of a top view of what that will look like. You're going to be connecting here, here, and here with an equilateral triangle, each side r, so 2r will be the side of the triangle. Now think about, where is this altitude in relation to that triangle? It's kind of logical. It's going to go right through its centroid, right through the middle of where that would be, because that centroid is the circumcenter. It's equidistant. There's no reason why it would not be equidistant from the vertices of that equilateral triangle. So now we're kind of curious, how we're going to work with that. Let's draw one of them here. We're going to draw one sphere kind of on the side here, coming down here, and it's not going to hit the height. Remember, the height is actually in the middle of it. And I don't want to draw all three because we got a 2D board and those are 3D, so it's kind of hard to draw that. I just want to draw this part, okay? So now if we think about where this altitude is coming from, okay? From the center of this sphere, I'm going to connect to that altitude, right? And I'm going to come down here to the base of the cone. This is resting off the base of the cone. That distance going down is r, okay? What else do we know? Well, for one, if you connect from the sphere, like if you have a circle, right, and you have a line tangent, okay, at that point of tangency, if you draw the radius, you get 90 degrees. So whenever you have a tangent line to a sphere or a circle, draw that radius there. Make it 90 degrees so you can look at it. Because by looking at it, it might trigger your next course of events. Okay, and as a reminder, all my solutions are my solutions. If I do borrow one from somewhere else, I'll attribute it. I don't have any problem doing that. So you might see somebody else do it differently. You might even had a faster way, and I love it when you guys leave comments for those ways. There's been 2 on this test alone where you guys just super impressive. I can't believe it. I pinned both comments. I think it was on problem 17, and I can't remember the other one off the top of my head right now, but yeah. Okay, so what's going to go on here though? What's this distance from the center to there? That's the distance in an equilateral triangle from your vertex to the centroid. So if I call this 2r, then this is r, 30, 60, 90. And what you want to remember about centroids is they're 2-to-1 ratios they create with the median that passes through them. So the thing about equilateral triangles is the centroid is the circumcenter, is the incenter, it's all of those things for an equilateral triangle. So we know that this height going here is going to be r root 3, but we want 2/3 of that. So this piece right here is what we're looking at, let's see, what would it be? 2r, 2 root 3 over 3r, if you will. That is this distance right here. I'm going to erase this 5 so I have space to write there. The distance right here going across is that right there, 2 root 3 over 3r. Okay, then how is that going to help us? We're trying to find this r, right? Well, it's also perpendicular here. And since this distance going down from that point where they intersect, where the radius extended intersects, is r, this part of it is 12 minus r. And that 90 degrees and this 90 degrees gets me thinking, maybe we should draw the hypotenuse, because that would be a right triangle then, right? So I drop down to here, and now I've got a right triangle here and another right triangle here. And we know this is 13. What's this distance here? Well, that's the tricky part. See, again, if you're outside of a circle and you connect to here and to here with two tangents, those are equal. Same thing is true for spheres. Same thing. So because the radius of the cone's base is 5, we can call this 5 minus 2r root 3 over 3. And because that distance is that, so's this one. What does that make this distance here? Well, it makes it 13 minus that. And you will have 13 minus, it's minus this expression. So when I do 13 minus 5, what am I going to get? Right, you're going to get 8. And then it's minus this and minus the negative. You're going to get plus 2r root 3 over 3. Okay, now keep in mind this is the 90 degree angle and this distance is r. I'm going to do two sets of Pythagorean, whatever you want to say it, and the hypotenuse is going to be set equal. Well, actually the hypotenuse squared. So let's get to that. We're going to have r squared plus this expression squared, 8 plus 2r root 3 over 3 squared, and this needs to equal the other side. 12 minus r is the long leg here, squared, plus what is this piece right here? Again, that's 2 root 3 over 3r squared, or 2r root 3 is more traditionally written, squared. Okay, I think we're ready to solve. We just got some algebra to do, and we're out of here. All right, so you're going to get r squared here. I'm going to expand this using a plus b squared, a squared plus 2ab plus b squared. So you're going to get 64. I like to multiply this with this and then double it. So 16r doubles to 32. So you have 32r root 3 over 3. And then plus, you should know 2 root 3 squared is 12. 12 over 9 is 4r over 3. But you know what? Why are we even bothering? I'm just going to call this whatever squared. You know why? Because whatever squared is right over here too, and it's on the other side of the equal, and I can just cancel it. Again, remind yourself, you're not proving anything to a teacher. You can just cancel things. You don't have to show all your work or anything like that. I know it's normal. You want to do that from school. Just cancel it, right? You don't have to show it, okay? It's for you. You're doing the work. As long as it makes sense to you, it's fine. Just don't make mistakes when you're doing it. So then you're going to have over here 144 minus 24r plus r squared. I already saw an r squared. We're going to cancel that and cancel that. Let's move the 64 over here so it becomes 80. I like to have positive numbers. Negatives cause problems. And you're going to move 24r over here. So I've got 32r root 3 over 3 plus 24. I'm going to pull this r to the outside. And that's it. We're going to do a little bit more now. What do we got? We got equals 80. So let's multiply by 3 and get rid of it. Okay? So I'm going to multiply by 3. I'm going to have r times 32 root 3 plus, this is 72, because this has to be multiplied by 3 as well. And that's going to equal 240. Now, you might want to divide by this, but I'm not. I'm going to look at this and go, gosh, I think at least 8 goes into all 3 of these. Let's just divide it out now. R times 4 root 3 plus 9 equals 8 goes into there 30 times. Now, I'm going to move over here. I'm going to have 30 over. Let's get rid of these circles. I'm going to have 30 over. It's just getting hard to get that low, you know what I'm saying? All right, 30 over 4 root 3 plus 9. And I'm going to multiply by the conjugate. What's bigger? This is going to be only 48. So I'm actually going to multiply by 9 minus 4 root 3 on top and bottom. And that's going to make it a positive denominator, so I don't have to worry about the negative at the end. And just pretend it's facing the other way. You're going to get 81 minus 48, because 16 times 3. It's difference of squares, right? So on top, I'm going to leave this as is for now. I'm going to do this subtraction. I'm going to add 2 to 50, and I'm going to add 31 more to be at 33. So my denominator is 33. I see that 3 goes into here 10 times, and 3 goes into here 11 times. So I've got 10 times 9 minus 4 root 3 over 11. I'm going to glance over at my answers now. And 10 times 9 is 90, and 10 times that is 40. We've got it. It's B. Okay, that's it. I will see you guys in whatever problem I do next. I don't know what that's going to be. We'll find out. Let's get to it.